morning, everybody. Good morning. All right, I hope everyone have a seat now. First, I'd like to say thank you for being here and joining us on this Corrosion Technology Forum Day. Exciting for us here at the Southeast College. But first, let me introduce our president, Dr. Melissa Gonzalez. She has a few words.
Good morning. How are we all? Good morning. Good morning. Yeah, hi. I am so excited to be here. We are so excited to have Corrosion Technology Day right here at Southeast, home of the Corrosion or Material Science Center of Excellence. So again, we're so excited to have so many students, so many people, so many dignitaries. And again, I just want to thank you so much for this opportunity. We're going to have a fun-filled morning. We're going to have talking about what careers are there in corrosion, what is corrosion, right? That's a good one as well. And the business of nanotechnology. We also have the programs. We have the corrosion technology program right here. And so we definitely want to share all the opportunities there are right here at Southeast Campus. And also we're going to hear from students. Isn't it amazing to hear from students' success stories from students that are taking the program right here, right now. So again, we're looking for an amazing morning. We hope that you are filled with knowledge of corrosion and the interest of corrosion, the importance of corrosion here in our Houston area. Again, I want to thank you so much. Again, my name is Melissa Gonzalez, and we have the Chancellor and the Board of Trustees. We welcome you, and we want you to have an exciting day right here at Houston Community College. Thank you so much.
All right, next I'd like to introduce Dr. Maya Donovan. She's a Chief Entrepreneur Initiative.
Good morning, everyone, and how wonderful to see all of you here. So the staff has really planned a really exciting day for you, and part of it is about how do you start a business? How do you design that? And that's really my role at HCC. And we've got some wonderful programs here to help you think about a business, come up with ideas. We have competitions. It's really an exciting place to plan your future and also to think about maybe owning a business. So Houston Community College is the only college in the entire country that has two very large programs. We have the Goldman Sachs 10,000 Small Business Initiative, which is grant funded to help businesses grow. And then we have a grant with the Minority Business Development Agency. It's called MBDA. And that helps minority-owned businesses grow through contracts and access to financing. So you'll learn about this as you move through various programs here. But in the meantime, well, before I have you fill out this form, I want to introduce the staff that works in entrepreneurship and small business development. Here at the Southeast College, we have Brenda Rios, if you will stand up. She's the director of the Southwest Center for Entrepreneurship. We have Ronnie Brombaugh, who is the director, there he is in the back, at Southwest College. We have Ned Miller, who's our entrepreneur in residence. So they do an incredible job to support you. So all of you have a little form that says Office of Entrepreneurial Initiatives. If you would fill that out, it only asks for your name, your address, your contact information, and then what are you interested in? If you're interested in starting a business or you have an idea, fill it out, and then we will be back in touch with you to find ways to help you and to support you. So you all have pens right there on the table. Fill it out, and you'll get on our mailing list. And as we have a lot of workshops and events, so we invite you to come and join us. Most of those are all at home. So we look forward to working with you and enjoy the day. Take lots of good notes. Everybody's filling out. Wonderful. Okay.
Thank you, Dr. Donovan. Again, my name is Campbell. I am the Dean for Material Science Center of Excellence here at the Southeast College and the Parcel District. I would like to just say a couple of words again quickly. I'd like to introduce our program coordinator, Mr. Jerry Ratliff. He's here. And also Dr. Mondale, full-time professor of corrosion technology. And all our staff are working in the program as well. Next, I'd like to introduce Ms. Jen Brown. She is CEO of Brown Corrosion Services. Ms. Jen Brown also our advisory chair, board chair, for corrosion program. And today we also have our membership, a member from our advisory board as well, attending here as well, supporting us. So CM Nelson is right over there, and do a demonstration later on. We have a table there from the advisory board member. Okay. So without further ado, I'd like to introduce Ms. Jen Brown.
Good morning, everyone. This is exciting to see so many young people who might enter our industry. I would urge all of you, after you hear our talks this morning, to approach any of these gentlemen on the left side of the room, and they can give you more specifics on what's available to do in this industry and how you can get into it. We're going to talk about what is corrosion. I think everybody knows the word. Some people know how to spell it, some people don't. But it's an important part of our infrastructure. It's an important part of society, and it's a very costly part of what runs this country. So we're going to talk about that. All right, the global impact of corrosion. $2.5 trillion a year is spent on corrosion issues. That's 3.4% of the global gross domestic product. That is a huge amount of money. And I think for all of us in the industry, one of our goals is to save money so that that money can be spent elsewhere. We all know that there's poverty, there's social programs, there's the arts, there's a multitude of other things that that money could be better spent on. So if we do our jobs well, hopefully we can help that process. Now, what is corrosion? In its simplest terms, when we energize an iron oxide or an ore from the ground, we put energy into it, we mine it into, say, pipes, steel structures, things of that nature, and then as it ages, it loses that energy and it tries to return to its native state, very simply. So as corrosion professionals, our goal is to arrest that process so that we can extend the life of mainly metal structures. What corrodes? What do you see around you? Bridges. The Golden Gate Bridge is something a lot of people are familiar with. It's made of metal. It's in a constant state of corrosion. It's always degrading. There have been some pretty big bridge failures. Luckily, we haven't had one in Houston, but they happen all over the U.S. Your home. Who here has had a water pipe failure or a gas line failure in their home? I think probably many of us. Our favorite corrosion people, we love when it happens at home because then we know we truly have not been as good as we hope we are. But it's everywhere. Your automobiles. It's not as pervasive in Houston, but if many of you have the opportunity to travel to the north part of our country and you look at vehicles that are more than 7, 8 years old, you see a lot of them on the bottom have rust spots, corroded doors, their bumpers are corroding, mainly from the salt that's put on the roads during the winter. We also get rust on all of our toys and gadgets. Your kids' swing sets in the backyard, your fishing rods, things that are sitting around your hose brackets in your house. Everything corrodes. Big things, but it's also the little things. Ships and marine. Again, being in Houston, a lot of us know we have a huge marine industry around here, and a lot of their work relates to keeping the ships from corroding. And then, of course, what probably the majority, about 85% in the corrosion business, are working in the oil and gas industry. And so Houston is the hub for that. It's a big part of our economy locally. Hopefully we're on the upswing right now, and it shall remain a good potential source of employment and profits for this country. This is a map. I'm not sure how well you all can see it, but of all the pipelines in the United States. If you look around you, under your schools, under your freeways, down the back of your homes, there are pipelines everywhere. Sometimes, if you look, you'll see little round, usually yellow signs, and they'll say, if digging, please call so-and-so, or if there's an issue, please call CenterPoint Energy. All these little signs you see around, that means underground there are pipelines. They are not only sending gas to your home, they're transporting all sorts of chemicals, fuels, additives, all sorts of things all throughout the United States. So they're everywhere. Keep your eye out for them, because when you start looking, it's shocking, especially in our city as it's grown, how many are in our own backyards. Why do we care about corrosion? The biggest part of the corrosion industry is we're trying to stop things from rusting, and in doing so, not have major explosions, pipeline leaks, failures of bridges, failures of nuclear sites, so that we in turn can prevent loss of human life. Our biggest goal has to be to protect the folks around us, to make sure that the people who are being serviced by pipelines, nuclear, energy, all these different things, keep their services intact and they do it safely. Loss of property. Again, if we have a bridge go out in Houston, that can cause economic hardship for people getting to work, for the city having to repair it, for the time you're going to spend away from your jobs, your kids, your family, sitting on the roads waiting for that bridge to be fixed. It's really critical. And then again, nowadays, we all know that there's lawyers. And when there's lawyers, it means time, money, expense, and difficulty. And if there is a major corrosion failure, there will be lots of lawyers involved. And nowadays, people are being held accountable for corrosion disasters. They're going to jail, they're being fined. So it's a really, really important critical issue that we keep everything as corrosion-free as we possibly can. These are a few major corrosion failures that have been in the news. Some of you might recall some of them. A lot of you look far too young. But in 1992, 215 people were killed in Guadalajara, 1,600 buildings damaged when there was an internal corrosion failure on a pipeline. That's a big loss of life, huge. And it happened instantly. From nothing to something, 215 people killed. The Nanotechnology River Bridge, 3 were killed. The bridge collapsed. You can see from a car, I believe, did go down into the river again. The bridge had not been maintained as had been recommended. And that unfortunately happens in the world, you know, as different groups come in and they manage different projects. Sometimes we don't do our jobs as well as we should. But as, thank you, regulations get better, we are also hoping to manage our corrosion issues in a more timely fashion. This one, I think older folks remember it because it was so dramatic. This was an Aloha Airlines flight in Hawaii. The skin of the plane actually separated, and one stewardess was killed when she was sucked out of the plane. but it did land. These people were still strapped into their seats when it landed. I'm sure they've experienced lifelong trauma from going through it, but that was a corrosion issue. Galvanic corrosion issue related to the rivets on the skin of the plane. Prudhoe Bay. Now, there was no loss of life in this one, but there was a major spill. And as we all know, there's a great emphasis now put on keeping our environment clean, safe for the animals, and not change the, I'll say, footprint of the environment more than necessary. And so when we have a spill, not only does it damage the environment, but it damages the reputation of, the oil and gas companies or the nuclear companies or whomever is involved in creating these energy sources that people use. Again, the Maltese tanker failure, it was split in two. This was actually a materials issue. They, in order to save money, had cut down on the amount of steel used in the tanker, and it was not robust enough for the service that it was put into. So when we talk about corrosion, not only are we trying to stop it from happening once we have all these metal structures in place, but we're also trying to initially design them properly with the right materials and the right corrosion inhibition put in place initially so that this type of thing does not happen. And then our favorite, the Statue of Liberty. I don't know if anybody's had the opportunity in the last 10 years to go up to New York and see the statue, but it has been closed a lot of the time because they have been mitigating the corrosion issues on it. If you go, it is a purely metal structure. It's very interesting. The green patina on it, of course, was an intended, I'll say, corrosion occurrence, but they did have some major infrastructure issues with it while it's been closed. So again, corrosion is everywhere. Another one a little closer to home, in 2000, there was a Pecos River failure. Two families were camping under a bridge. There was a gas leak, a gas pocket, and then an explosion. And I believe 13 people were killed. So again, not only was there a loss from the public with faith in the oil and gas company, there were also families devastated, and then there was huge cost, not only to the oil company that had the failure, but there was also a cost to the industry in realizing that maybe we had not done our jobs as well as we could have, and having to make a significant number of changes so that we could more ethically and technically meet the corrosion needs of our systems. So when we talk about controlling corrosion, we only have a few methods. We have protective coatings, or what many of us would call paint. We paint everything from our cars to our patio furniture to our tanks to our pipeline. If you all go down to the ship channel, you drive by hundreds of tanks. Some of them are beautiful. They have nice white paint and nice logos on them. And then some of them, if you look at them, look a little bit shabby. So do we like the nice looking ones? Yes, but there is also a purpose to that. That helps protect those tanks from external corrosion. We then have cathodic protection, which again is a way of energizing a system so that we can drive the corrosion to a sacrificial piece of material as opposed to the material we're trying to protect. We also initially hope to do good design work. Through material selection and knowledge of the correct materials to use in our design, many corrosion issues can be controlled before they even become an issue. Materials, which again the corrosion school here at HCC deals with, they talk about what's the right material to use in a given project. If you have a very small amount of metal that's being used, you can use a higher grade of stainless steel, a hastelloy, some of these new materials. But if you're building a whole pipeline, you have to realize that probably you cannot afford the economic term of using the best materials. So instead, you use a lesser grade metal, but then you have to use other protection methods. And then, of course, we can modify our environment to deal with corrosion issues by changing the chemistry internally of our systems, adding chemicals to help control corrosion, lots of different methods like that. We're not going to get into this, but a corrosion cell is what drives everything we do. We're trying to change every process so that we can slow it down and control it. And the HCC program gives students the tools to know how to do this. And it goes from very simple to very complex very quickly. And we are going to have somebody talk about corrosion careers after, so I'm not going to get too heavily into it. But what do corrosion people do for a living? All of us in this industry have an overriding goal to slow down corrosion. You cannot stop corrosion, but you can significantly slow it down. So everything we do relates back to that. Better coatings, better materials, using chemistry to change the process, using cathodic protection to drive the corrosion down. And then, of course, initially designing better structures. In the U.S., when we initially started installing pipelines 90, 100 years ago, people would put up pipeline in service for 20 or 30 years. We now have pipelines that have been in service for 60, 70, 80 years. So as much as we consider ourselves a throwaway society, the reality is for major metal structures, most of them, we need them to stay in service and we need to extend their life as long as possible. There's some pipelines being painted. Part of the corrosion industry, and many people go into the coatings aspect of it. Not only are they responsible for coating a pipe, they're responsible for inspecting it, for making sure that the coating that's put on is put on properly, in the right thickness, that it's allowed to cure properly, things of that nature. And that's one aspect of corrosion control. Golden Gate Bridge. The Golden Gate Bridge is continuously being painted or recoated. 24 hours a day, 365 days a year. Somebody is always on that bridge painting it. I don't know if I would want to be the painter doing that bridge, but go through the program, maybe you'll be that guy or lady. Cathodic protection. Again, this program at HCC, part of the area of study is related to cathodic protection, which of course is learning to energize systems so that we can slow down the corrosion process. Cathodic protection is all underground. We bury anodes, which are sacrificed to protect, say, the pipeline or the tank bottom or any metal structure that is underground or offshore. And we energize that system through rectifiers. And if the system is put together, everyone is unique. It is designed for the application that it's going into. And again, if you work in the aspect of cathodic protection, you could do everything from surveying the systems, to installing them, to designing them, to maintaining them. There's a whole multitude of things that you can do that relates to this specific area. Material selection. You can see in this photograph on the left that material selection is important. You cannot join two metals that are dissimilar because one will always sacrifice itself for the other one. And this is what we don't want to see. Not only does it look unattractive, but of course it's going to lead to a corrosion failure at some point. Who works in corrosion? We have field technicians, lab engineers, lab technicians, researchers, salespeople, paint applicators, and equipment manufacturers. They're a fun group of people. This is a great industry to be in. It's very diverse, men, women, every color under the sun, every religion under the sun. Whatever you want to be, you can succeed through corrosion. There is some aspect that will meet your needs. And I think most people would say in corrosion, one of the things we're most proud of is it's a supportive industry. It's an industry that you can make good friends in. We always call it our little dysfunctional family. But it's a great group of people all over the world. There's about 40,000 of us involved in this business. And it's whatever you want to be, you can find success in some aspect of corrosion. Now, let's come to our specific program at HCC. It is a 2-year program, and we are hoping that the folks who go through this will graduate as corrosion technicians. A corrosion technician, and again, there's a lot of variety in this, but generally, it's an independent job. You work in the field, often by yourself, so you have to be a self-starter, you have to be motivated, you have to be able to think on your feet and come up with solutions. I'm not going to lie, it's not an easy career. There are long hours. For many of us, there's a lot of time away from home. But again, if you want to see the world, this can also be an opportunity to do that. Every day, new challenges. I think if you all speak to any of the corrosion folks over here, they will tell you that every day they run into something new that they're not entirely familiar with. And they have to find new solutions, they have to do new research, and they have to come up with new solutions to the issues they find. One of the sad realities of our business now is most of us, especially if you go into the oil and gas aspect of corrosion, you will have to pass a drug test. If you choose to have extracurricular activities of that regard, this is probably not the industry for you. Drug testing is continuous. You can't pass your first one and then go back to your old lifestyle. It is an ongoing process. As well as that, we do have many requirements, especially if you work in the Houston area. You have to get government clearance, which is a TWIC card, which allows you to work in refineries, marine, things of that nature. And if you have a record, that can restrict the ability to get that card, which would again restrict your ability to be in this business. And unfortunately, that's just the reality of having the opportunity to work in this career field. You do have to mind your P's and Q's. I tell everybody that I think, and this is how I started, the greatest opportunity you have in corrosion will be starting at the bottom. You don't start at the bottom. It's awfully hard to know, A, when you've hit the top, but also to hit the top, because every day you gain the knowledge that will lead you to the next step in this business. And although starting at HCC gives you a good base, the best learning you can get in corrosion is doing the work. And so I would encourage all of you to consider this as a profession. I think all of us here, and I'll say myself in particular, I've been doing this for 28 years. I started out wiring corrosion instruments for a company when I was in university. It's been a worthwhile career. It's been challenging, it's been interesting. I've had the opportunity to work all over the world, but I started at the very bottom. And I learned, I'll say the hard way, I didn't work for much money at first either. I started pretty low, but I've learned as I've gone, and it's turned into a lifelong, worthwhile, very fulfilling career. And I would encourage you all, you know, they say now that millennials in particular like to jump careers every 2 or 3 years. And that's one way to get ahead for sure. But I would contend that there is a great joy in being in one business and becoming an expert and becoming an authority and really knowing what you do, loving what you do, and looking forward to going to work every day. And if you don't invest in a single career choice, I think it's very hard to get there in any career path, jumping around. Also, corrosion is a career that I think anybody could be proud of. You're protecting people, you're protecting the environment, you're doing something challenging on a daily basis. It's very thought-provoking, it's diversified, it's global, it's science, engineering, salesmanship, personal relations. You're going to do it all in corrosion. I think all of us in this business have found that even though we said, well, I'm going to be this aspect of corrosion, you do everything. You're representing your company when you're in the field. You're talking to landowners. When you go out to survey their pipelines, you have an opportunity to interact with both people who are helping you dig out a pipeline in a ditch and also the CEO of a company or the chief scientist responsible for creating a new coating. You get to deal with all these people, and it's really interesting. There's a lot of knowledge, and people are very willing to share it, so it stays fascinating. Again, corrosion is all around you, and that's about it. But I did want to say I've been with this program since we started it about 6 years ago. We're very proud of where we're getting with it. The industry is very supportive of this program being the leader in the U.S. for a 2-year corrosion technician program. There are a multitude of jobs out there. They're available. We're looking for hardworking people. We believe in this industry, and we hope that some of you will have the interest to get involved and eventually have a wonderful career out of it, make good money, and enjoy yourselves. Thank you.
Thank you, Ms. Van Brown. So just like Ms. Brown just mentioned, right, I'd like to take the opportunity to really welcome and introduce. We have 120 students in here. Okay, so one of you can stand up. 120 students from program. Give them a hand. This is our future here. This is our future, right? You just heard from Jens mentioned, right? You know, we need a new workforce here, so you are it. You are it. Okay. All right, thank you. All right, so I would like to introduce our next speaker. Our next speaker is Mr. Tom Stanback. He was once HCC graduate, okay? And he moved along in his career, and he spent the last 16 years working at his corrosion technology program. And here, I would like to introduce you Mr. Tom Stanback.
How's everybody doing this morning? Are we all going to wake up? There's a lot of people out there and stand on and not really paying attention to what's going on. All right, what does this says up here? My name is Tom Stanback, and I'm here with TRC Solutions. I'm going to be live streaming so I can speak up a little bit. Sorry Okay, so if you're attending our program, what does a base certification actually cost you in Stanford? Well, you're looking at around 1900. Guys, can you not hear me back there?
Hello.
Is this better?
Yeah.
So going through the program, we'll actually look here and take the test. What is this test actually? You're in the perfect market to get into your career. Houston, Texas, that is the biggest city in the country. Still can't hear me? I'm embarrassed. We better now?
Yeah.
Sorry, I'm not used to speaking. So Houston, Texas is really the focal point of the corrosion industry for the entire Gulf Coast region. If we look at a map of the city of Houston, blue is going to be natural gas lines, red are going to be hazardous liquids. These are just the main transmission lines going throughout the city. On top of this, you will notice that there are probably every 30 feet within the city, distribution lines running off these main lines to buildings, houses, structures. If we expand out and you look at the state of Texas alone, same natural gas, same hazardous liquids. Are we seeing a trend here? Pipelines are everywhere. Oh, when you take a look at the country as a whole, you'll notice in this area down here, how many pipelines are we seeing, guys? Too many. No, not at all. That means money. So if you look out in the outlying middle portions of the country, not nearly as dense. But when you get down here in the center, this is the place to be if you're looking to get your foot in the door. So what kind of jobs can you provide with a corrosion background? For existing assets that are already out there, GIS data management, hydro testing and validation, traceable, verifiable, and complete work, integrity management planning, inline inspection program design and implementation, and corrosion integrity field services. There will always be operations and maintenance positions for people looking to work. For new existing assets, sorry guys, front-end engineering and design is a huge money. Pre-commissioning surveys after the lines are constructed, survey and mapping, cathodic protection system design, CP system installation, and GIS-based asset lifecycle tracking. Every action that's taken on the pipeline, whether it's a repair, a new addition, is heavily documented. Everything has to be permitted through the federal government, and records have to be kept. There will always be positions in that as well. Now, there are two different career paths you can have in this industry: field work or office jobs. Who out there wants to travel the country? Anybody? Really? All right, good deal. Who wants to sit in an office, not work out in the sun, do a bunch of paperwork? All right, we've definitely got work for you too. So field work careers, you're going to have things like construction, engineering, inspection, any form of geotechnical engineering or testing, right-of-way inspection and maintenance, hydro testing, integrity survey, non-destructive testing. You can become a certified welding inspector, or you could also become an API inspector and work inside plants and facilities. Office jobs. I know some of y'all wanted to hear about this. You could become a records clerk, a document controller, survey data processor, GIS engineer, data analyst, integrity management professional, or enterprise replacement coordinator. Sound fun to anybody? Yeah? All right. Where are you going to look for your first job after you end up getting your first certification? Anybody have any ideas? No, nobody? Not a single person. There are many websites online. RigZone, OilJobs.com, NACE even has a jobs board if you're going through there. Through University, Houston Community College has a placement agency. There are numerous recruiting events throughout the course of the year here in the Houston area. The Houston Pipeliners Association, I'm not sure if anybody else from there is out here today. Yes, no? All right. Recruitment agencies are a great way to get your foot in the door. If you've never worked in the industry before, you're not going to have the strongest resume tailored to an actual position you find on the company's website. Recruiters may be able to help you learn what kind of skill sets you're going to need to emphasize to these operators. Here are some of the major operating companies out there. These are just the larger ones. PG&E, Kinder Morgan. Spectra, I believe, has now become Enbridge since I put this together. ExxonMobil, Optimum Grid is going to be an electrical distribution company. They heavily use our services for inspection. So the three things to remember and take away from this. You are never going to stop learning and advancing. If you get into this industry, this NACE CP1 certification that is the ultimate goal of the program is just the first one you're going to obtain. Over the last 16, 17 years, I've held more than a dozen different certifications in different facets of the industry. You will always have a test to take coming down the road, and you will always have continuing education, which you have to stay on top of. No one owes you a job, and that is the one thing I've learned the hard way in this industry. There are times where the work slows down, there will be layoffs. This is a reality of the industry. You always want to be the best at what you do. Never let anybody stand in your way of getting the things done you need to do. And the other thing that I don't see emphasized anywhere that needs to be taken into account, keep track of all the projects you work on, the hours you spend doing it. A lot of your certification will require documentation of hours, as well as verification that you actually do the work. You will have to have managers sign off on this documentation, and it will undergo an audit. You better be ready for that. Who likes to keep track of their own stuff? Nobody? No. Yeah, it's something you gotta do. So now I'm gonna open up the floor. Anybody that has any questions about finding a job, working in the industry, let's hear it, guys. I think Tam's going to come around with the microphone. Anybody?
Tom, I'd like to ask you questions. You was an HCC graduate. I wonder how you share with the audience how you get into corrosion industry field.
How to get into the industry? Well, before I started doing the project, I had been in direction drilling consulting for probably 5 years with well analysis down in Tucson. Back in 2009, the price of oil tanked. I mean, we went from $150 a barrel down to about 27. I found myself unemployed 2 weeks after my doctorate. Well, it turns out well log analysis and pipeline integrity analysis are very similar. I ended up getting a job. Oh, it looks like we have a question. I ended up getting a job with corrosion inspection and learning to do inline inspection analysis.
So Edgar's a little shy, but his question is, how do they get those pipelines under the ocean, and what kind of job opportunities are there to work in the ocean?
Okay, well that's not really a beginner job. If you're going to do something that's 2,000 feet under the water, first you want to learn how to do it on land in a much safer environment. But I mean, to answer your question, they're running off ships and dropping down very large cranes.
Hi, my question is, what kind of industry certification have helped you along the way? industry certifications that are pertaining to this type of job?
Okay, so I hold certifications from SPWA, which is the Society of Professional Weapon Analysts, the American Petroleum Institute, or the API, NACE, the National Association of Corrosion Engineers. It's really specific on what you're going to get into. Some people, such as project managers, are going to get a PMP certification, which is Project Management Professional. Or if you're getting into the safety side, CSP or Certified Safety Plan.
Another shy one. She's trying to figure out starting pay. So starting pay and the time to get certification.
Oh, I mean, that's a very broad ranging question. You can't really give a definite answer to that. You would have to come up with a specific position. All the certifications take a different amount of time to acquire, and every position pays differently.
So like average time to like get into that type of education and like going to like college and like learning how to get those opportunities and like how much you would actually earn, like try to help you earn.
Okay, so I guess a rough answer to your question. College is going to be 2 to 4 years, depending on what you go into for a bachelor's. If you end up getting an engineering degree, it could be 4 or 5 years. If you go for your master's or doctorate, you're looking along the lines of 6 or 8 years. After that, plan on spending 6 months for your first job. They're not going to be the highest paying positions. I mean, $15, $20 an hour with a college degree. However, if you stay in the industry, that will substantially increase.
Let me add to Mr. Steinbeck just answer the question. Here at HCC, we start out with certificate level 1, and then we have a 2-year degree as well. Right? So you start out with program here at HCC, and with that program, you start to get into the industry. And after you're done with certificate here at HCC, and the opportunity for you to go and get the one of the NACE certifications, which stands for National Association of Corrosion Engineer, and that NACE international organizations is really created. It's founded here right in Houston 60 years ago, okay, by a group of corrosion engineers. So that's where the path you're going to start, and then of course, you know, getting a job and learning throughout the job, so you're learning your career upward from that end. I have one more question, Chief.
I'm curious how much y'all make in this career.
Yeah, how much you making in a career?
I'm very sorry, I'm not going to answer that question.
Okay, so we talk about what, I mean, that's what everybody wants to know. How much am I going to make? Well, I would say to you, what are you willing to put into it? We have corrosion technicians that after 5 years in the industry make $100,000 a year. Now, are these guys sitting on their couch and hanging out with their kids every weekend? No. They're spending 5, 6, 7 weeks in the field, or out every day, 16, 17 hours a day in the hot sun, busting their you-know-whats to make it happen. This career will be what you make of it. And so yes, you are maybe going to have to start at the bottom. You might be a wire puller. You might be putting together parts or instrumentation. You might be doing something simple like processing data on Excel spreadsheets. But if you have the drive, the initiative, and the desire, I would say to some degree, the sky is the limit. We have salespeople in our industry who, many of them started as corrosion technicians that are now making $200,000 a year in sales. But again, they're working awfully hard to get there. So it is a career that you will make whether you're successful or not, and how much money you make, and how much you're willing to travel, how much you're willing to learn. how many additional certifications you're willing to get. It's all on you.
Mr. Stanback, I had one question for you and one question for the corrosion. You, Mr. Stanback, I want to know what is the deadliest chemical for, on the bridges? Like using it. Yeah, the increase.
To build the bridges?
Yeah. Well, not like building, but protection.
Well, chlorides or salts can damage for corrosion, but if you talk about what can kill you, especially in the oil and gas industry, it's hydrogen sulfide. Many of us work in those environments. If there is a leak of hydrogen sulfide, it can kill you. So there is an element of danger to this industry, which is kind of exciting as well, for those of you who are interested.
No, I just had to ask.
Yeah, no, there's, like anything, chemistry has a lot to do with how things corrode, but also how safe they are to work in. I believe, help me out here, somebody in corrosion, 2 or 3 years ago, we had the leak of H2S down at, was it BP, and 3 guys got killed? Help me, somebody. So it happens. This is not, we would not be honest if we told you that this is an easy industry to be in. You have to work safely. You have to be considerate of what you're doing all the time. There are a lot of safety aspects to it. But again, that goes to the challenge. Are you up for the challenge to get a really rewarding career that you can, frankly, make a lot of money doing?
This is for the corrosion people now. I don't know, like how long does it take to get to the place that y'all live in? What is the most scariest, bridge you ever been on? Like,
you know what? I know the perfect one for this answer. So, yes. Nigel, take this one.
Okay, I'm going to go back to a little bit of a few other questions in there. Okay, starting salary in this business, if you come out of college, can be anywhere between $12 to $26. Most important thing I'll say to you all, get a good education. Yeah, it starts now. The better your education, the more salary you're going to get. Okay, you've got to put the effort in. The jobs are out there, but that's just starting salary. Okay, I'd like to answer your question. I've been in this business 30 years. Where did I start out? Obviously, I've got a funny accent. I hope you can understand me. I came across the pond. I grew up in England. I worked in the Middle East. Talk about a scary place to work in the 90s. Every time I went there, a war broke out. I mean, luckily, we had you guys come over and rescue my ass. You know? Because otherwise, I was jumping on a plane in '91 in Kuwait. Talk about a scary scenario. We were getting on a plane out of Kuwait airport, flying out there was planes burning on the runway. That's just what happened to me. I'm not going to say that's going to happen to you, but here's an opportunity. I've worked in this industry 30 years. I've probably been in 60 different countries. I get paid to go there. And you want to pay for your travel. You want to go and see the world. Here's a business. So you can be lucky at it, or unlucky at it. Scariest product? I don't know. The scariest product is the one that hurts you. Okay? We have areas that we classify in our pipelines called high consequence areas. I believe all pipelines are high consequence areas. If it lets loose the gas where you're right next to, that's pretty high consequence to you. And the industry over the years has progressed. I mean, it really has. I mean, back in the 30s, well, even before that, in the teens, 20s, 30s, when most of this infrastructure was laid, there was no regulations. And we had a lot of explosions. The biggest one was here in Texas, in New London, 1937. 634 school children, 40 teachers. Blew the school apart. They could feel the explosion 40 miles away. That's how bad gas can be. So it's a product that we have to look after. And it's an industry that is very conscious of this. We're regulated so much these days.
All right, thank you very much. I would like to present to Mr. Tom Sandbeck a little plaque here just to thank you for your participation as keynote speaker. Jane Brown, may I ask you to present this?
This says, in special appreciation for your support of the 2018 Corrosion Technology Forum Day. You know, if I can say, guys, as well, when I went to college, this is just a little aside, my dad, who was also a corrosion engineer, had been hit with one of the downturns in the corrosion industry, and he said, we cannot afford 4 years at a big school for you to go to, so you are going to start at a community college, which I did. Got an associate's degree and then went on and got my bachelor's. You, as Nigel said, have to start somewhere. And going through the community college system is a very cost-effective way for you to get your foot in the door. And you will make your career what it is, but HCC or any other community college can help you in that next step of finding a good career path and committing to something that you can enjoy for lifelong that will provide you income and hopefully challenge and happiness, which is the point. If you're gonna work, you might as well enjoy doing it. So, you know, consider this program strongly. In the material science group, I know we're hoping we can expand things and get more aspects of corrosion and materials considered, but Tom's a great example of if you start right after high school and keep at it, you can find success. So congrats, Tom.
One other thing I'd like to mention, all of the major operators in this industry offer tuition reimbursement. If community college is your only choice due to a financial situation, it's a great place to start. Get your foot in the door, then take advantage of your employer's tuition reimbursement programs to attend a four-year university while you're working and making money. Great idea, huh? Here you go, Tim.
Thank you very much, Tom. Okay, I'd like to introduce our next speakers. As you heard from Ms. Jen Brown or from Mr. Tom Stanback, he mentioned about how to protect and mitigate corrosion, right? We talk about two different things. The first one is coating, painting, and the second one is carpet protection. So it is my pleasure here to introduce Mr. Mahesh Patel. He's the CEO of Sayo Nano, and the company is focused on nanotechnology. So keep in mind the corrosion technology as well as all the technologies, all the industry is working together in collaboration to make sure we mitigate on corrosions. And here's one example.
Good morning, everyone. Okay, so in my presentation, I have only one slide, and you may think it is being done purposely to make it uninteresting. And the reason is, lately my family and friends says that I'm getting more and more attention seeker, so I wanted your attention here. So I'm at this slide, and this is what I have in my presentation. So I'm going to talk about the nanotechnology and commercialization in nanotechnology. From 120 students we have present today, anyone would like to enlighten on the nanotechnology? Yes, please.
Nanotechnology is a field of technology that is used to create new materials, 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 new materials,
what is nanotechnology?
Technology will provide any prevention if we can't even prevent on our own thing with our hands. So none would help anything else any other way and provide our percentage of succeed.
Good. Anyone else from this side? Sorry? Sure. Nanotechnology is manipulating atoms and molecules. It's called as nanotechnology. Have you heard about any application of nanotechnology? Cancer treatment, yeah. Okay. So, what? Sorry. Yes.
It's everything about the whole structure of things. So the like enhancing the structure of atoms can really help you like to enhance the lifespan of certain materials and
Yeah.
all that. So it has a lot of applications in the medical industry, like cancer and all those things, and also in the industry like coating certain type of materials, the drilling bits and all that.
Just adding on a general example, like imagine your driveway was coated and it never got wet again because you added a waterproof coating on it. Or your furniture in your backyard had a coating on it and it never got wet. Your clothes never got wet because you have a nano coating.
So far the world has evolved where last 10, 20, 30 years you would have understand the material science basically on the micro level, which is called as 10⁻⁶ micrometer, 10⁻⁶. Nano is 10⁻⁹. That means it is 1,000 times smaller than the micro size. And what it does, it allows us to understand science at that level, manipulate that, and get the desired performance or property from the material. So we can play with that. Sometime in 1987, scientists in IBM, they come up with a tool, and using that tool, they wrote IBM atom by atom. So nanotechnology allows us to exploit their properties to make a different applications. And it's not only for the computer science or medical, it would be applicable to everywhere. The clothes we wear, the furniture, the automobile, everything. In every applications, nanotechnology can be used. Specifically for material science, it allows us to develop different kind of materials, as Ravi mentioned, that coating. So you can have a coating where you can have a hydrophobic coating or hydrophilic coating, depending on the applications we require. We can make a conductive coatings. Now, science is working towards a new dimension where coating, we can generate electricity from the coating. So you have paint on your house, and it has some photovoltaic material inside that, and that generates electricity for the house. So these are the new applications coming up in the coating application. The product, today I'm going to talk more about the entrepreneurship and commercialization. So I grew up in India. I had this idea 20, 25 years back when I was doing my chemical engineering. And that time I was not knowing that what I'm doing is nanotechnology or going to be a nanotechnology one day. So those days, When I started in India, we did not have enough facility to do this kind of research. So I used to struggle to get this kind of access for the various equipment and the tools. And I used to travel various parts of the world to learn about it and then to figure out what I can do out of this, because those days, like you guys, I had no idea what to do in business. But I wanted to do something new in the world, something challenging in the world. So the question was asked in the previous discussion that how much you make. Now, my idea was not to how much I make, but what can I do? So I was more focused, and that's where the entrepreneurship comes. So, so today's focus is more on entrepreneurship. So, do you want to work for someone or do you want to hire someone? So entrepreneur hires people. So keep this in mind, what you want to do in life, what is interesting, and believe in that. Whatever you want to do in life, just believe in that. And that's where we are different from the other people. So I started this journey in India, and slowly we did some research and figure out what kind of products we can bring into the market. Now, those days, world was different from today, 20 years back. So we decided that we will not go for a high-fi application of nanotechnology, but we will go where we can help the conventional industry to use nanoscience and technology. So in coating applications, the last big research in material science for coating application was done in 1945. So 1945, titanium dioxide started application in paint industry. Before that, it was the zinc oxide and lead and other chemicals. Then there's another product which came to the market, was in early 1980s. So very few new material came into the coating applications. So we know primary purpose of coating. What is that? First, protection. Second, appearance. Now, when we need a new appearance, we need to cover the old appearance. So when we apply coating, what happens? Light travels through that and comes back. Now, if light reaches all the way to the previous coating or the substrate, then it would be a kind of a transparent or semi-transparent coating. And then what's the purpose if it is not covering? So titanium dioxide is used to bend the light. So we have noticed that when you put a pencil in a glass of water, it looks like the pencil is bent, but it's not pencil bending, but the water bends the light, and because of that we see. So what this material does, titanium dioxide, it bends the light, and the light comes out of the film of the paint. So we come up with the idea where we design a new material which bends the light the way titanium dioxide bends, and we have been successful replacing 25% of titanium dioxide in the paint, and titanium dioxide is the biggest cost in making the paint. So this is the product we wanted to launch in the market. So and meanwhile, I got a call from Singapore Economic Development Board, it's a government agency, and they have a plan to make a nanotechnology focused area, and they were inviting people from the world. So they invited us to Singapore and started this company. And we did a couple of years for research and product application development, and in 4 or 5 years we finished that. And when we are ready for launching this into the market, we got a good interest from American market, and we decided to come to USA. So last year we started our first production facility here in Houston, Shepherd, where we are making nanomaterials in a ton scale. So the biggest challenge in nanotechnology is the cost and the production. You might have heard about the name called carbon nanotube. How many of you have heard carbon nanotube? Okay, it's very exciting material. It's very expensive. It ranges from $20,000 to $100,000 per kilo. So, yes, it has a great promise, but what matters in commercialization is how much customer can pay and what benefit customer gets by paying that. So the big challenge for the nanomaterial commercial scale is the cost of making that. So we come up with the idea that no matter whatever the conventional price of the titanium dioxide, we will match that price. And still we will be profitable. So that was the basic strategy behind commercialization. And at the same time, we wanted to successfully make on a larger scale. So currently we produce in a ton scale, which is considered a very big volume for the nanomaterials. And that's where this slide comes. I'm not sure you're able to see this graph. So, is it visible? Yeah. So, what it indicates is the particle size distribution. So let's say you have a particle, some particles you have 2 inches, 8 inches, or 20 inches, right, in a mix of particles. But if you make a 20 inches particle, that's your target, and if you make 80% of that, that's a big success. Now, at nanoscale, what we are able to do, we are getting 281 nanometer size of 100%. So that's the beauty of the process where we get our desired size. And why 280 nanometers? Because the average light wavelength is 560 nanometers. So as per the physics law, if the material is half the size of the light wavelength, that's where you get the maximum bending of the light. Thank you. Any questions?
So one of the questions was, take yourself back to the high school. What were you thinking about?
Sure.
You were in high school.
Sure.
That made you an entrepreneur.
So right from high school, if I go back today, I was very clear in my mind what I wanted to do in life. And I wanted to do my own business. I wanted to do something new in the field, whatever I do. So that's not.
So you said you didn't know you wanted to be work with nanotechnology. How did you find that?
So when I was working on this science, I was really not knowing. See, the term nanotechnology coined when I think in late 90s, Bill Clinton came up with this couple of $100 million for National Science Foundation. That was the term. That was the time when this term became common. But before that, I don't think there was a specific emphasis on the nanotechnology word. No?
She doesn't want to stand up. She has a question.
What is your educational background to be a CEO of your company?
I'm a chemical engineer, and I have done some management program. So, okay. In India, we have a very famous institute called Indian Institute of Management, Ahmedabad, which is famous like a Harvard university here in America. And I don't want to follow what I'm doing, but I'm just telling my story. So after the chemical engineering, I got into the MBA program, and within 4 or 5 months, I finished all the books of 2 years reading. And one day I was deciding, I'm not going to work for anyone, so I don't need a degree, so I just dropped out. So those days in India, government of India had a program to scout for people and from whole population of more than 1 billion people that time, they were scouting 5 people and putting into that program for 20 months. So I was also selected in that program for that 20-month program. And then the day I was going for my final signing of the paper, I was thinking, why I'm doing this? If you have to swim, you have to jump into the pool. You cannot read the book. So I dropped out of that also. However, so I'm not discouraging. You should do MBA. So my philosophy is I do a gap analysis that for the next 5 years, what are the skills I need for my business or for my professional career, and that only for that program I go somewhere. I went to Harvard, I went to Kellogg, I went to Berkeley, and only for that time I do this small program where I learn that skill. Yes. Sure. Just mic so I wouldn't get the question.
Yes, thank you. I'm trying to visualize nanomaterials. If nanomaterials lying on the table, what would it look like? Where do you store it? How do you store it? Just put it together. The chemistry part of it.
So, nanomaterial, it doesn't mean that it will be in an atomic size and that's where we are using. So this here, if you see, it's 280 nanometer size. Now, when we provide to the customer, it's in a slurry form. It's a slurry. So, that's what your question is? Yeah. So some nanomaterials are in powder form, some nanomaterials are in slurry form, but it is not straight away used. It is used for further, industrial applications or something.
So fun question. Which superhero has the ability to change shifts that has to do with nanotechnology? So you guys, X-Men or Marvel characters, which superhero has the ability to change their shapes? The Hulk. And then Hulk? Hulk, well basically Hulk just takes the atom and I guess they grow the atom so it gets bigger. But is there a superhero that can actually change into anything? Because technically, at nanoscale, you can change the entire chemistry of an atom to build a new atom. So, okay, you guys. Which one? Mystique. Do you follow Mystique?
I just only follow nanotechnology.
But that is an application of nanotechnology in Mystique. Because in order for her to change into any character, she has to change at the scale of an atom.
So we are in a very interesting situation in the world today, where it's like a cycle. So we come up with a new material that develops a new tool that allows or creates more capability to understand the material or science, and from that understanding we develop a new material. So we are in a very interesting stage in the life where this technology is kind of getting traction. So every day you find a new science, I'll not say new science, but something new coming up in understanding the science, and then new applications. So both are evolving. Thank you.
Thank you, Mr. Patel. I would like to ask Mr. Ravi Rambach to present you a recognition for participation in the Corrosion Technology Forum Day. All right, thank you very much. Is that exciting? And we go from corrosion and go to nanotechnology, so the sky is the limit, okay? The sky is the limit, and thinking that, you know, what your next study, what your next learning going to be. Learning never stops. Okay. All right, so I would like to now introduce our program coordinator, Mr. Jerry Ratner. All right, so he looks handsome. Some of our students here will recognize Mr. Ratliff with the white coat, okay, every day. So today he dressed up for this occasion, so give it a hand. All right, so Mr. Ratliff has been in the corrosion industry for a long time, and now he gives back to the community by working with the HCC, by teaching the student, you know, put his heart into the teaching every day in every classroom or every seat for the, with the students. So without further ado, I would like to introduce Mr. Ratliff, and he's going to talk about corrosion technology.
Good morning, everybody. It is so good to see all of you. I, as Dr. Lee said, my name is Jerry Ratliff, Professor Jerry Ratliff, and program coordinator, and can you hear me okay? Is this better? Okay, I'm the program coordinator and instructor of corrosion technology. And this morning we are going to talk about corrosion technology. We've done a lot of talking about corrosion and corrosion technology, so we're going to get into corrosion technology and especially our program. So, let's talk about why you're here. Well, you're here to hear and see industry and to gain some insight into a potential career choice, as you've heard throughout the morning. I'm going to take you on a little journey in the world of corrosion technology, which, as you probably figured out now, is quite vast. The expected outcome of my presentation is to expose you to a discipline that is not very well advertised, especially at the high school level. And we want to make you aware of this career choice. And this educational opportunity exists right here on your doorstep. One of the greatest places to be in this business. We have it all right here in Houston, in the Houston area. Houston Community Colleges, also known as HCC, is looking for a few good young men and women who might be interested in the corrosion technology program. And the reason is you are soon to embark on the next journey of your lifetime, whether you are prepared or not. It's going to happen. And as adults, we can tell you that a large, uncertain, and very competitive world is right outside your front door. Now is the time to start to think seriously and consider your options. And embrace the reality of your future. That could be a frightening thought. I'm thinking back when I was where you are. Because for the most part, we really don't know what we even want to be in many cases. I know I didn't. Well, I missed that one. I don't know how to go back. So, what does your future hold? Are you going to go to college, vocational school, a job, the military? Any number of possibilities. And as adults, having traveled those pathways and having sat where you are, we know full well that it is great to have a starting point, a starting advantage. And knowing what I know, I highly recommend that if at all possible, choose as best you can a profession, a job, a college that feels right for you, because in many cases, you may find out later on that it doesn't suit you. And I can tell you from experience, I worked many years for a major oil company. I worked for ExxonMobil for about 36 years, and I saw a lot of young people come and go, and I cannot count on one hand all of the young engineers who had spent all the time and effort getting an engineering education, and once they got there, they said, not today, this is not for me, and they went on to other disciplines. So that's why I say try as best you can and try and find something that fits you, that feels right. But I can tell you that regardless, education is the key that will unlock your future. That's a guarantee. And it's the one thing that no one can take from you. And this is very important. Always remember that success happens when preparation and opportunity come together, or when they meet. Think about it for a second. All the opportunity in the world can come, but if you're not prepared, you can't take part. So, with all that being said, let's move on to corrosion technology and what it's all about. As you've heard, it's a far-reaching field. Energy, infrastructure, manufacturing, medicine, transportation, national defense, yes, Army, Air Force, Marines, they all have major corrosion sections. They even have their own books. So you could be in corrosion in the military. Corrosion technology utilizes chemistry, electricity, metallurgy, and other sciences to prevent and control corrosion damage. And whether you know it or not, corrosion is so very important to each and every one of us. Actually, we're all paying for it, whether you know it or not. It's costing you money. So we've talked about corrosion. So exactly what is corrosion? Well, one general definition of corrosion is the deterioration of materials, usually metals. And let me clarify, all materials corrode in some way, shape, form, or fashion. Now, you're probably more familiar with one form of corrosion. Who all is familiar with rust or rusting? Show of hands. Everybody know what rusting is? When some people rust? Okay, all right. Well, that's just one form of corrosion, okay? So the definition, the deterioration of materials due to chemical and or electrochemical interaction with the environment exists. Basically, you put something outside, that's its environment, it interacts with that environment, and corrosion happens. As of 2013, corrosion cost the U.S. about $1 trillion and growing. As I said earlier, we're all paying, so we're paying about 3,000, each of us, we're paying about 3,000. If you take the number of people in the U.S., about 325 plus million people, and divide that into $1 trillion, you come up with about $3,000 a year for each of us. And we're paying through taxes and so forth. And what that is direct cost, things that you have that corrode and become unusable or fall apart. And the other part is the cost that industry, manufacturing, the food service pass on to you. Because whether you know it or not, every can of food on your pantry, corrosion has been considered. In years gone past, you had a can of tomatoes that's very acidic. If you left them too long, they could corrode right through the can. That doesn't happen anymore because your cans are all lined for corrosion protection. And as you heard, it can cause very serious damage, and including loss of life. And it damages everything from vehicles, home appliances, water and wastewater, pipelines, bridges, roadways, and public buildings. And the thing about corrosion, it's a natural process. Just as natural as water flowing downhill. And there's a reason for that, and that's one of the things that we teach in corrosion technology, that you'll learn why that happens and how we can prevent that, or mitigate it, slow it down, and in many cases stop it. The corrosion control industry is a stable occupation that will always be required. As long as there are metals, there will be a corrosion industry. And the occupational need, or the need for new people, is rapidly growing as a result of our crumbling infrastructure, our reliance on energy, and the attrition rate of trained people in this business. There's a big void that developed. I know at the end of my tenure with Exxon, in a meeting, I'd look around and all the corrosion technicians were old people. And one day I said, where are the new people? So somewhere we dropped the ball. And that is the reason for programs such as ours. We're not just doing it on purpose. There's a need for it. Not to speak of government regulations that drives the need. Every day, there are new government regulations that have to be taken care of, and the government is serious. In many cases, you can be incarcerated for not telling the truth or doing things contrary to the rules. We talked about corrosion, jobs in corrosion, and where do technicians work? Indoors, outdoors, installing, maintaining, inspecting, troubleshooting, all sorts of facilities, such as pipelines, storage tanks, buildings, building components, industrial equipment, airplanes, yes, airplanes, ships, rail cars, electrical transmission system, yes, all the wires you see running around overhead carrying power, yes, serious corrosion problems. Water services, remember Flint, Michigan, and transportation systems. all the roadways, bridges, and so forth. What knowledge do corrosion technicians have? Well, they have notice the word basic. So you don't have to be a chemist or an electrical engineer to work in this business. But there is a need for a basic understanding of electricity, chemistry, and metallurgy. And at HCC, we teach you how to put those things together and make them work. So corrosion engineering or corrosion technology is the application of science and technology to detect, monitor, and control chemical, electrochemical, and mechanical deterioration of materials and systems. Let me just say this. Not all corrosion is bad. Most is, but not all corrosion is bad, because everybody in here, well, I'll ask it this way. Who all has a cell phone? Show of hands. Okay, do you know why your cell phone works? Corrosion. Something is corroding in the battery. And that's the stuff that you learn at HCC. And as you heard earlier, corrosion technicians can specialize in any number of areas of the corrosion control industry. And it's not just out on the pipeline. You can work up in the ivory tower. There's jobs for everybody in this business. Coatings, inspections, cathodic protection. Mrs. Brown mentioned cathodic protection is where we use electricity to protect metal. Sounds crazy, but it works. As well as material selection. Some materials, as we learned this in metallurgy, are less prone to corrosion than others. So, for instance, take gold. You might see a little tarnishing on your gold, but you don't see much corrosion. But that tarnishing is a form of corrosion, just on the bare surface. Okay? And it's a very broad discipline and plays a very important role across the entire American industrial complex and infrastructure, to include all industries. So don't just think of corrosion as oil and gas. All industries across the spectrum uses some method of corrosion control. Whether it's material selection, if you think about the medical industry, you know, most of their tools, their scalpels and scissors and calipers are all stainless steel. There's a reason for that. And the field of corrosion technology is solely dedicated to stopping, controlling the process. And as I said earlier, a large and ever-widening void for trained people exists currently in the U.S. Some basic job requirements. Look what it says to get started. Basic corrosion, basic chemistry, basic electricity, general math. You heard about certifications, level 1 certification, recommended but optional. Definitely recommended but optional. You do not have to have it, but if you do have it, that's a big plus. And we prepare our students to sit for the level 1 NAE certification. So you walk in the door with a certification, and that's a good thing. There's a preference for hands-on, but again, not everybody works outside or work with their hands. Preference for outdoors, because most of the corrosion takes place outside. and travel may be required, not in all cases, but in many cases. Now, here's what we offer here at Houston Community College. We are our courses, Introduction to Corrosion, with a basic chemistry component, because we have to understand the basic chemistry in order to understand the corrosion process. Basic electricity, atmospheric corrosion control, very important because the lion's share of corrosion is atmospheric. And why is that? Because most everything we have, with the exception of pipelines and tanks, is above ground. Introduction to metallurgy. Non-destructive testing and evaluation. And one of the reasons for that is one of the ways that we monitor corrosion, or how well our programs are being effective. You heard a lot about cathodic protection, and that's using electricity to protect metal surfaces. And level 1 certification testing preparation. As you were told earlier, we offer a level 1 certificate in corrosion technology. That's a 1-year program or 2 semesters. Also, there's an Associate of Applied Science degree, 2 years or 4 semesters for those who want to continue on and maybe even go for a 4-year degree. But the the certificate is more aimed at people who may want to come in and learn a trade and go back out and go to work. Scholarships are available for those who qualify. Employment opportunities, where are the jobs? The Department of Transportation, huge. The oil and gas industry, the dairy industry, the food industry, pipelines, electric power industry, the medical industry, electric cable telephone companies, utilities, water, wastewater, sewage, maintenance of facilities, vehicles, auto, heavy equipment industry, wind energy or green energy. Those turbines you see turning out there, they're out in the atmosphere, right? So there are definitely corrosion problems associated with those. Of course, solar energy, bridges and roadways, the welding industry, metallurgy and polymers or plastics, the fuels industry, serious corrosion problem in the fuel industry, and government agencies such as the Environmental Protection Agency, I'm sure you've heard of that, OPS, Office of Pipeline Safety, the USGS, or the U.S. Geological Survey, and, as I said earlier, the Department of Transportation. Now, earlier, the question came up about salary and average pay. And since I was going to talk about this, I got the latest numbers on average, okay, for the industry, on average. And the answer is, drum roll please. That's average for the industry. $23.49 an hour or $59,000 annually. Now, as you heard, that can go and of course, it can be less, but that's the average. And I'm not going to stand here and tell you that you walk out of HCC or any other school, well, most schools, in most disciplines, and walk in and make top salary. It just does not happen. You have to gain experience. You got the education, but that's just the key. Now you got to do the work. You have to prove yourself. Now let's talk a little bit about corrosion. Let's bring it home a little bit. Corrosion in our everyday life. Corrosion is silent. It's called the silent menace. It's happening while we're sleeping. Actually, we have a saying in the industry, corrosion never sleeps. As I said earlier, as of 2013, the overall cost of corrosion to the U.S. economy had reached the $1 trillion mark. How much is $1 trillion? Does anybody know? A lot of money, right? And you know, when we talk about billions and billions and trillions, we have a problem trying to get our mind around it, right? I mean, we know it's a lot of money, but we don't know how much money. So let's take a look at this. Now, without doing the math, without even turning your mind off, as far as any calculations, if a person saved $40,000 a year, how many years would it take to save $1 trillion? How many years? Okay. A, 25 years. Now I'm going to ask for hands after I finish. B, 2,500 years. C, and I think I'm going to run out of space here. C, 25,000 years. And D, which is below, is 25 million years. Okay, let's see hands for 25 years. Okay, 2,500 years. Nobody? How about 25,000 years? How about 25 million years? Okay. And the answer is D. Now, does that give you some kind of idea of, you knew that $1 trillion was a lot of money, but socking away $40,000 a year would take you 25 million years to save $1 trillion. Do we have a little bit better feel? So that's how much money that corrosion is costing. That's just the U.S., that's not the world number. Let's talk about metallurgy for a little bit, which is the science of rendering metals from ores and making them usable. Like the bus you came in, the engine, the shell, the wheels. It all started right here. That's called iron oxide. It can be quite pretty stuff in a lot of different colors. We take that and we take it to the steel mill and we beat it and bend it and dump it in a lot of fire. Okay? And then we stir it up, and then out comes red hot steel from that little brown rock we saw earlier. And we take that steel and we make beautiful parts. Very usable equipment. Steel building materials. Steel materials also for building. Automobile frames, the bus frame, for instance. Nice shiny screws. It all came from, but let me tell you a little secret. All that stuff you looked at, it is not happy being what it is. It wants to be that brown rock. And that's what you learn when you come to HCC. Well, it's all about thermodynamics. So basically what it wants to do is, everything we saw wants to go back to being that brown rock. And the process is the process of corrosion. That's what corrosion is all about. Okay, now, getting ready to wrap it up here. Let's look at some of the faces of corrosion, which I think might, let's tie corrosion to what we see every day. Let's look at vehicle corrosion. Nice, huh? Ain't happy being nice. It wants to look like that. That's heading back toward the brown rock. Our job as corrosion people is to keep that looking, not looking like that, but looking like the picture we saw before. Another very nice. The corrosion got a hold of it. Nice wheels. I'm sure you got some nice wheels on your cars. Corrosion don't like them. That's a leaf spring. Usually find that on trucks. To smooth out the ride. Exposed to a lot of water and everything off the road, right? That's what happens when corrosion takes hold. Structural corrosion. Nice bridges and towers and skyscrapers. Ain't happy, wants to be that, wants to go back where it came from. Corrosion at work. Bridge collapse. And this is anywhere USA. Okay? Is that something that's near and dear to our hearts? That was involved in that tragedy? Now, another thing. When you're zipping along on the highways and byways, driving 70 miles an hour in your nice car, being happy, you have no idea what's taking place underneath the bridge or the roadway. For instance, I'll give you a little tip. I-45, there's a lot of this going on underneath I-45. Just be thankful there are corrosion people, such as myself and others, especially the table to my far left over there, that work every day, try and keep us safe. And out of sight, out of mind. Yes, concrete problems as well, because you know what's inside the concrete in many cases? Steel, metal. And heaven forbid you put salt on the road, that just exacerbates the problem. Here's a lucky guy, the road just fell right from under him. That's what's happening under many of the roads and bridges. Beautiful aircraft, and a little corrosion problem causes this to happen. Went right through the building, corrosion related. Now, this next slide is one that Mrs. Brown had shown earlier, but a little bit more about it. This was Aloha 243 flying over the state of Hawaii. It left the airport looking like that, and miraculously, it returned like this. That happened at 24,000 feet. Top came off. 96 people aboard, but only one fatality. And there's a movie about this, quite interesting. Get a chance, look up Aloha 243. Because part of the structure was gone, and the only thing that was holding the nose to the rest of the plane was on the bottom, and it was just bending as it was flying, if you could imagine that. And corrosion related. Oh, one other thing. And guess what, ladies? The pilot was a woman. Brought it down. Brought it down. Pipeline and platform corrosion. Well, that's the end of that platform. Look where this explosion happened. You heard earlier about pipelines running underneath. Think about downtown Houston. Every building has water, gas, telephone, all underground, right? Every neighborhood has many pipelines. This one was unfortunate. You can see the house, the pipeline ruptured right in the middle of the neighborhood. Corrosion. Roadway corrosion. A total catastrophe, total explosion, corrosion. Thank you. Okay, one last thing. That's what we do as corrosion people. And so please, by all means, if you have any interest, there should be some forms that you fill out, plus I think you signed in. Come and talk to us, because we love to have new people in the program. We're trying to expand the program, and it's the only one in this area of the country. And so now, without further ado, I would like to introduce our next speaker, one of our own, I might say rather. One of my students, one of my very good students. Please help me in welcoming Miss Celine Wynn.
Good morning, everyone. Like I said, I'm a student at HCC, so I want to start off with a little activity since we've all been sitting for a while. And so, if you have any jewelry, earrings, necklace, watches, please stand. I know some people aren't paying attention, so you might want to tap, hey, you got your earring, necklace, rings. If you had braces, go ahead and stand up. If you had a cavity or a crown cap, go ahead and stand up too. If you drove here, go ahead and stand up. If you rode a bus, go ahead and stand up. We're getting everybody involved. Is corrosion involved in it? Now that our legs are all stretched and we're about staring at our phones for a minute, go ahead and sit down. So when I first started at HCC, I actually was not in the corrosion program. I was actually nursing. So I started back at school for nursing. I did a semester. It was all biology stuff, and I found out that I'm not good at biology. So my mom suggested that I go to a seminar provided by Dr. Lee. And so my brother and I went to the seminar.
I was so confused. The corrosion, anodes, cathodes, all that. It was just a big mess. But Dr. Lee told me to give it a try a semester. So I tried a semester. And I'm still in it now. So. So quick quiz, everyone. What is H2O? Water. So H2O with hydrogen and oxygen, known as water. So my second question is, what is NaCl? Chloride. Alright, so I'm going to try to answer it from a student perspective. What it is, why, where, how, from mine. So corrosion is, as everybody's already mentioned, it's a deterioration of metals. It can happen on the bridges, nails, medical equipment. So if you had surgery, I'm pretty sure they had to use some kind of metal equipment to operate. Why did it occur? It occurred because the element is trying to return back up to its original form. Corrosion can occur in the rural, the urban, industrial, and right, bridges, cars, out in the country. So, as you answered earlier, H2O, which is water, and sodium, it creates a faster corrosion rate. Salt and water increases the corrosion rate, like you just said. It creates less resistance between the metal and the solution. And most of, well, the marine time has a lot of salt water. Examples are, like they mentioned before, the chemical plants explosion and stuff. And so we live around that area here in the East. Corrosion around the bridges, it's a major concern. So there's always somebody trying to fix it, prevent it, or code it. Big bridges, structures might play a part in the bridge collapse. The state has identified needed repairs on 12,000 bridges, which the state estimates at $8 billion, and that's just in Texas. Corrosion can occur on the inside of pipes, not be seen easily. Deterioration of the pipes show that pipes will be compromised. Another picture of the we've heard, or most of us have heard, the Flint, Michigan crisis, water crisis, and how the lead was in the pipes, so all the water was contaminated. How can we prevent corrosion? Well, by studying corrosion, we can prevent it. We cannot stop it, but a major way of preventing corrosion is through coatings and the separation of the water. There are plenty of job opportunities that y'all want to take a look at work. It's all there's many job opportunities. Corrosion and technology. Like I said, corrosion is all around us, especially you noticed earlier with the electric. Everybody's saying. So at HCC we do have knowledgeable instructors. The classes are small so that you can learn more, and if you have questions, you can ask the instructors. And there's a lot of financial opportunities.
A question for Senator Win. since you coming in, and we talked more than a year ago, and your brother as well. You both just graduated certificate level 1 in May, and I wonder what made you continue into a 2-year degree now.
Well, like you said, or like I said earlier, I started here with my brother, just so that I can help him out, because he started studying engineering. He did about 3 years of engineering, and he's got nowhere. All he's really good at is math. So I told him, let's go ahead and give the program a try. Maybe a year and a half, and if you don't like it, at least you just wasted a year and a half compared to 3 that he did before. So he joined the program with me. I started back into the schooling, and ever since then, it's just been like a competition between myself and my brother to see who can get the furthest and who can get to the end and who has more knowledge in the and so far I believe I've accelerated my brother, but he's pretty much up there too, and so we're both trying to see, we're pushing each other and encouraging each other, but it's also like a little sibling rivalry.
Thank you. I'd like to add to about our program that it's also very exciting for us here at HCC in our program that we've seen. You just heard, Celine and her brother is Alex in the same program before graduated. Okay, a year ago we also have a mother and son also work through the program as well, and now we currently have a mother and son, and also the father in the program as well. So it's a good supporting community, so if you have a friend go along with you, you're going to be successful, and you need that. You need that support around you. So you don't turn anything down, but also offering that to others. I could not tell myself that I'm getting here without support from friends, from family. Okay? So take that off and move forward.
I'm not. I just finished the program, so right now I'm starting to look for any, internship or any, just like a starter, like a beginner. Entry level, sorry. When I first started in the program, my first class was actually with Professor Ratman. And I believe there was about 20 of us in there, but there was only myself and another female. So I felt like it was a little scary trying to be in this like male-dominated field, but I chose to stay in the field and try to accelerate them too, because if they're gonna sit there, I want to be on the same page as they are too, but I actually want to be better than them. Because if I feel like I could accelerate them, I could do it out in the field too. And so most of the guys, they just looked at me as a girl just sitting in the class, but they didn't see me as a threat until at the end. But then they're like, oh man, she's been in it the whole time. She's been in the game.
Thank you, Celine. So allow me to introduce our next speakers, actually. First is Dr. Renee Abraham, and also Dr. Sushi Mondale. So this is Dr. Abraham, Dr. Mondale have been working together. We work from different departments, right? And let's Dr. Mondale introduce about the work of Dr. Renee Abraham. But at HCC, we love the collaboration with Trinity Department because everything we do is connected. As you can see today, it's a collaboration between the two COE Center of Excellence here, Material Science and Material Science as well as the Office of Entrepreneurial Initiative. Okay, so we promote that. So this is another at the technical level. The two professors working together, and then the two classrooms actually they work together to come up with this exciting presentation. Not just that, but actually the work that they do to help the student learn better, you know, in the field. So with that, I would like to introduce Dr. Mondale and Dr. Abraham.
Hi, my name is Dr. Sujit Mondal, and I will not give you any hard-coded lesson. So my first question is, how many of you guys like to play the video game? Oh, I have a lot of students for future. So, you know that the corrosion is a very fascinating field, although it is a deterioration of the metal, and it is electrochemical in nature. And we teach the basic fundamental aspect of corrosion over here, and also we have a laboratory equipped with all modern technologies to detect corrosion and find out the solution for corrosion. But if I talk about corrosion all the time, right, I know that you guys are listening from 9:30, you guys probably sleeping. So I will talk about first a story and then my product. So you need to understand in life, three things is most important for me. That's what I have understood. I come from India, and now I'm making my life over here. Wisdom plus preparation plus opportunity equal to success. Okay? And I will start with a small story and just listen. Once upon a time, among the birds, they decided that they will find out a king. And the bird, they told each other that if we fight like a human being, then we'll destroy our species. So what we will do, we will try to fly high, and the bird will reach the highest altitude, will be our king. So an eagle was flying the highest altitude, and when eagle was about to be announced the king, then a small parrot jumped from his back and started flying high. And everybody was surprised. So in the courtyard, when the kings sit down, which will be the sparrow, because they have to decide if the sparrow went to the highest altitude. So everybody asked the question, the king, you are so small creature, how do you fly so high altitude? And sparrow says, it was very easy. I was sitting on the back of the eagle, and eagle was flying, and he tired, and then I started actually flying. So that's why I'm telling you guys, wisdom plus opportunity plus preparation equal to success. Okay? And long story short, here in the field of corrosion, we do a lot of experiment, and I will talk about one of the experiments over here, and then I will hand over to Professor Abraham, and she will talk about how the digital gaming can be done, interfacing corrosion or any field of material science. Okay? So, my next slide, if you guys can look at, there is one multimeter, and this multimeter can be used to measure the voltage or current. You can measure voltage or current of the metals. So many metals are there in the earth. We have learned from the morning, and those metals having different energy, and they can react at a different speed. So you can measure their rate of reaction by measuring potential or current. And then I put one of the instrument in an ammeter. You measure current through that, particularly current. And when you have to measure the current, there will be a reference electrode. Reference electrode will help you to figure out the potential and the current for a particular electrode or a metal. And now, if you look at what we do over here in HCC, it's called metallic immersion cell. And you can see that there are plenty of metals up there, different metals. Okay? And you can measure their potential by adding water and adding a reference electrode with the help of multimeter. Now, someday some student having personal issue, and he may not appear in the class. so you will miss the lesson, correct? So I was thinking how I can interface to help them to get the lesson done. And that time, Professor Abraham and we met in a Maker Faire event, and I came out with the idea that we will create a virtual reality game software. So whatever they will do manually, that will be in the virtual workframe. And we will upload that with the app, and they can play anytime, anywhere. And that's why our project, or the proposal name, is Study of Corrosion Anytime, Anywhere. Even you miss it, if you are in your home or if you are in your workplace, you can still work on that. So why we try to do that? Because it makes the corrosion class fun and interactive. Corrosion lesson become easy and attractive, and we can attract more students. So the greatness of a professor is to engaging the student in his or her class. And that's why we came up with this idea. And it is a great collaboration between the two departments, material science and digital gaming and simulation. And I will hand over the mic to Professor Abraham, and she will talk about how our two students built up this gaming software within 2 months. And they worked hard and they bring the result or the product. So Professor Abraham.
I think first of all, have my students come up because they need to set up the computer. So if you can walk up with the computer in the background while I make the introduction. Yeah, I am Dr. Rainey Abram, and I'm part of the team for the Gaming and Simulation program. I started the program back in 2005. It's going pretty strong. Because the name of the program is Digital Gaming and Simulation. So there is gaming, but once they come in, of course nobody wants to come in for simulation, right? So that was my trick, to put in gaming first, phrase gaming, so I can get you all in, because gamers like to come into gaming program. They don't want to come into simulation program. And I will teach you, our program teaches you how to put a game together from scratch. Always, you know, initially when I was the chair, I always said it's not easy to put a game. It's different than playing a game. But you have the opportunity now to create a game that is what you like. Let's try it, right? There's so many things about games that you play you don't like. Oh, they could have done it this way. Or this is, oh man, you know, I can't do this, I can't do that. And, you know, there's so many things you say, well, they could have done it differently. So I said, yeah, when they come for that interview, I said, yeah, you have this whole list of things that how they could have done their game better. So now, if you're really interested and can work hard, it doesn't come easy, okay? It's not an 8 to 5 job. When the project's done, it's a job. Okay? So you may not have to travel. You can sit in your little, I mean, we don't have any basements here, but the say is you can be in your basement in a corner. But wherever your home or your room is, in a corner, you can sit. Okay? You don't like, your parents may not like seeing you, so I have to educate the parents too that this is real. It does make some money. But what I do for the students is we teach them the gaming part. Then we kind of start introducing them to projects that is oriented towards simulation, which is more real in Houston, and they get better opportunities in Houston, because Houston is known for the oil industry, the medical industry, and so now they're also getting aware of what gamers can do is create simulations of training. Now, same thing for corrosion sites, you know? Instead of going to these dangerous places and learning how to do it, you don't want to fall off that pipeline or whatever and be, you know, exposed to chemicals. We can create a simulation that can teach you what are the safety procedures. And you do it, make mistakes, do it again, make mistakes, and you learn and you learn. And in this So our goal was to do one of the experiments at our class. And these students were part of, these two are part of the simulation, a project 2 class, which is the graduating group, and they do 3D projects. So this came in really good for pilots, and they 3D is really good. So I said, okay, let's go for it. Because they don't like me, they hate me, so they couldn't do a game, they had to do a simulation. But you see, there is, one of the things I tell my students, yeah, if you make a game, it's for you, mainly, to entertain yourself. If the game that you make doesn't entertain you, you have a big problem, okay? You don't make those happen. But then you have to find like-minded people also to play that game where you can make some money. You myself play the game, doesn't make any money, okay? You have to, when you prepare something, you have to hear the cash register go ching, 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 ching. If it doesn't, you don't hear ching, ching, it's useless. Nobody wants it, okay? So simulation, we have to market it, okay? So I want them to be exposed to have some portfolio pieces in that area, because that might be the next thing. And I'm thinking for the need for so many corrosion technicians, and not having that many, or we might have some training centers, retrain, or make it more interesting for the newer generation to train in these particular products. So what we did is, of course, I say to my students, when you're doing simulation, we are a service industry. We don't know anything about corrosion science. Okay? I'm a computer science programmer. I have to serve accountants, I've got to make accounting software, I have to make engineering software. I don't know anything about those things. But first thing we have to do is learn. We have to listen and learn. We have to learn. So, because you know, I'm the teacher, so they have to do what I tell them to do, right? So they had no choice. So I said, okay, these are the dates. Dr. Mondale is going to show us what he does when it's done. So we need to make that. You gotta pay attention. You got to record if you want to. You got to take pictures if you want to. Whatever you need, because artists need a lot of reference pictures. And the programmer needs to know the procedure, the process. Because if you don't know the process, then you cannot code it to do or mimic the process. So he also has to, and lo and behold, I committed for this before the semester, and I was nervous to hell, okay? Because I'm not seeing in my class roster any programmers signing up. I need a program, and I was getting ready, okay, maybe I'll have to be the I made this commitment, we got the grant to do it, I have a bunch of artists, it's not going to work with just artists, we need programs. Finally, one program, I found him and I said, James, aren't you registered? You gotta register. Don't you need this class? You need to graduate. And yeah, I need to register. Okay, finally you register. I said, okay, I have one programmer. I hope he sticks with it because you never know. These students, you know, there's life. It's not just school, there's life also, right? Life happens. So anyway, we got, 12 students. 12 students in the class. One was not very interested and kind of fizzled away, and so we ended up with about 11 students, and out of 11, 10 were artists, one program. And that's okay, because some of the artists are technical artists, so they can do, they're interested in the technical part, because when you do art, there's lots of different types of art. There's fine art for putting a poster or art piece on the wall. Then there's art for things which is different, how you have to prepare it. So, you know, we have to do art for games. And then, of course, I'll tell you a little bit about this thing, and after the presentation, I'll show you, because you need to come around and see that. So anyway, we put the team, and I selected Nova as the team lead because it's going to, our project classes always run as a business. Just like the gaming. Everybody gets a title and they have a job to do. So Nova was the team lead in the product lead, and then James was the only programmer. So he is the lead in programming, and then we had lead artists and all of that. So, and then we made 2 trips to this particular campus, and Dr. Mondale showed off his little talent of putting this project together. How do we, and he actually did a lecture in one of the trips. He actually lectured and taught us about corrosion science, which was fantastic. In fact, I'm telling you, he's a good instructor, okay? So you need to take his class. So they studied, they learned, they had the videotapes, we re-listened every time, said, oh, how did they do that? We went back to the video, listened, we looked at the pictures, details, because the pictures are important, because the 3D artists need to model that, and then they had to texture it and make sure they have the proper lighting and everything. So, and so we have James here, the programmer, and about they're the very dedicated students. We need them. We have a project. We need. I always talk about champions for degree programs, champions for anything, champions for a project. But they are my champions. In fact, there is a young lady who couldn't come. It's her birthday today, so I said I can understand. She was also a champion for the 2D side and did a lot of work. So let me turn it over to them, and they're going to do a short demonstration. And it is not just play the game. It's not, I mean, there is a scoring, there's a timer. There's also a tutorial part. There is also a video of Dr. Mondale doing the actual experiment, and we've incorporated that. But there's many elements to it. So, guys, take it over.
Hello, everybody. Hello, everybody. My name is Nawaf Al-Rawachi, and I was the team lead for this project. I am an alumni of Houston Community College West Loop campus from the Digital Gaming and Simulation Department.
Hello everyone, my name is James Ansir. I am the lead programmer for this project. I'm still a student at the HCC West Loop campus.
All right, so let's talk about this project. So Corrosion Lab, anywhere, anytime, it is a simulation, okay? It is not a game, and it was built on request. Now, why did we build this? Okay, we built it as sort of a prototype to show what technology can do if utilized in the education, okay? So we can utilize this technology. It doesn't necessarily have to be played on a computer. It can be played on a phone. We can utilize this to help educate people in whatever field of studies that they want to go in. So right now, before we go into anything, I want to show you the credits for this because I don't want you to know James and I are not the only two who worked on this, okay? So I do want to give credit to the rest of our team who actually helped us in finishing this project. Now, this acts as more of a proof of concept to what can we do in order to cut down on cost and improve efficiency, okay? As you may know, you do not always have the equipment ready for you at any time to do whatever it is that you want to study, okay? Which is why this is a good method to be utilized in that manner. So right now, we're going to select an experiment. Now, as you can see, there are a bunch of experiments in here, but they are not selectable because they have not been made yet. We have only made one, as I said, as a proof of concept, which is the metallic submersion board. Now, right here, before we start, we've implemented some features to help students know how the simulation is going to be played. So first of all, let's go into the how to play. Now, this game, or the simulation, is not played regularly, so you're not like grabbing stuff with a mouse. What we are utilizing here actually is something called leap motion, okay? Leap motion is actually this little dongle, I believe it's infrared, that will catch your hand, the movement of your hand in real time. And what this allows you to do is you're actually able to pick up the metal alloys and then conduct the experiment physically, as it were, okay? So right here, let's go into video tutorials. What we have is a small snippet of Dr. Sujit Manda conducting the actual experiment. And what this is meant to be as sort of a video to help students like remember how the experiment is actually done, or just practice their knowledge before they actually go into the simulation. Now, speaking of practice, we have two modes for the metallic submersion board. We have practice simulation, and we have start simulation. Now, practice simulation, let's go into that. Practice simulation will actually list the objectives that you need to do in order to successfully pass the experiment, okay? If you do not follow the objectives that are on the objective list, you will fail. So this will act as sort of like a test, okay, for you anywhere, so that you can keep practicing, okay? Now, let's go into the pause menu for a sec. We have some more features to help out people playing the simulation to keep track. So what we do is we have some slots where they can put the name of the metal and then the voltage readout that they get out of the multimeter. Now, let's go back in. In front of us, you'll see a table with a multimeter and the metal alloys on it, but we're going to ignore that for now, just for a sec. So let's walk around the room. Now, if you have actually been in this room, this is actually an HCC lab room. And we tried to the best of our ability and references to replicate the exact same room so that students feel more at home when they are playing the simulation. Not everything is 100%, but we tried to get it as close as possible. Now, let's go into the simulation. You will see that we have a multimeter, a water bottle, a bunch of metal alloys. We have some gloves, some goggles, sponge, and the container with the metal alloys in it. Now, in here, in front of each metal alloy, you'll see a blue box. Now, what is that blue box? This is what we call a placemat. Now, this is used to help facilitate or help you actually put the metals inside of the container. Now, leap motion is relatively not the best when it comes to tracking. So we made this as a mechanism so that you are able to actually snap the metals into place when pushing into the blue boxes. All right? Now, actually, we needed to pick up the goggles and the gloves. So you have to put the gloves before everything, and of course you have to wear the goggles as eye protection. Now also, they are not completely physics-based, so they will kind of come towards you and they will just kind of disappear. But as I said, this is more of a proof of concept. If we were to take it further, then everything would be pretty much physical. So you grab the goggles, you put them on your head, and they should stick there. Now right now we're going to grab the water bottle and we're going to take it over to the container and fill it with water. Now you see how the control of leap motion is kind of finicky, right? So if anything slips out of your hand and actually falls outside of the area in which you're supposed to play, we have a respawn or location reset mechanism so that everything snaps back exactly where it was. Okay? Now we have the multimeter in order to help you as well. we added a snap next to the container so that it just snaps there, and then you can see the readout clearly. Now you will see the container, the multimeter has 2 cables connected to it. So we're connecting one to the reference electrode and the other one to whichever metal that we'd like to test out, okay? And here, if we pull the cable next to the metal that we'd like to test, you're going to see that it's going to snap exactly to the location where the metal that you want to test is. Now if you want to reset the cable so that you can snap it somewhere else, all you got to do is you got to hit R while grabbing it, and it's going to snap right back to your hand. And then you can snap it anywhere else and continue on with the experiment. Now try throwing the cable out of bounds just to show what would happen. So you throw it out of bounds, see, it resets into the location where it was. Now, as soon as you finish the experiment, or the countdown timer runs out, you will get your grade or assessment. So you could have failed, or you could pass. But could be if you do some of the objectives wrong, then you will of course fail because you have failed to do so correctly. Now let's go back. Now, after you practice enough with the practice mode, you can go into the actual simulation, which will not have the practice mode, which will not have the objectives written for you. So you will have to know exactly what needs to be done. Otherwise, if you didn't, you can always go back to the practice mode. So right here, we're going to start right away, and we're going to try to do everything correctly. We're going to grab the gloves, and then grab the goggles. And then after that, we are going to fill the container up with water and then test a few metals. And this should give us a passing grade because that is what this prototype shows. It only shows just a few basic things that you can do. So once we do everything correctly, the timer will reset to 10 seconds, letting you know that you have successfully finished the experiment. If it does not, then you gotta check out your surroundings and you have to know what you did wrong, okay? And then the next time, or you could rectify your mistake and then perhaps get a passing grade. All right, before I let you go, there's one more thing I just want to talk about very quickly. Now, we as game developers do not necessarily only work in game development. What we can also do is we can bring whatever it is that we build into physical form. So right here we have a mini diorama for the actual classroom. And this is not just meant to show you, oh, like we can do 3D printing and that's it. No. This is... All right, what this can be used for is to actually help educators, not necessarily the students, but also educators, where they can give us, for example, a design layout or a plan, and we will be able to build that and then 3D print it and they can test it in real time. They can actually have a tool that we create for them based on their plans within hours. And they can test it out and see if it works or it doesn't. Okay? Now one more thing, I will wrap up. Me and my friend here, we could do freelance work. So if you are interested in any of these, anything from this field, simulation, whether it be it or 3D modeling, please come up to me. And ask me for my business card, okay? But please come up before 12:55 because I will leave by then. Alrighty? So thank you very much.
And I train them well. They can even, market themselves, right? So this is models that the students have created, and we actually printed with a 3D printer, and then I just super glued the pieces in place. So you can actually visualize the lab. You don't don't have to be in the lab. Okay. We'll keep it there for you all to see.
Thank you guys. And you can see the picture of multimeter. And with the 3D printer, I have the mini multimeter. And I will throw. So whoever will catch it will get it. Over there. Last one.
Thank you very much. We would like to express our thank you to Dr. Abraham and her department and her students. Jerry present a recognition to Dr. Abraham for her support and leading us through operation with our department.
And it reads, presented to Dr. Rini Abraham, Chair of Computer Programming, Digital Gaming and Simulation, and Geographic Information Science. In special appreciation for your support of 2018 Corrosion Technology Forum Day. Thank you so much.
All right, thank you. We are running about 15 minutes late, so we're going to speed up things a little bit here. I know I'm very hungry by now, and we have the lunch getting ready over there. So for the next 15-20 minutes, what we have, I'd like to introduce the two, first Mr. C.M. Nelson, one in the blue there, okay. Mr. Nelson will have a demonstration related to what equipment that we use for to really learning about corrosion cell. Okay, so we had a rectifier, he had other things that we would like for you to stop by and take a look and listen to what he's demonstrate. We also have Mr. Robert Harcher. He's with Ally High Tech. He also has the microscope. Metallurgical microscope, so we can look at the metal under the microscope to see how the high magnification level is. Okay? So with that, I think what we have to do, we have about 15-20 minutes spending with Mr. Nelson and Mr. Robert Hunter, and then we're going to start lunch serving at noon time. Okay? And we will wrap up around 1 p.m. Okay, everybody okay with that? All right, so Mr. Nelson.
Good morning. You've heard a lot of different things, and for a lot of you, I'm sure that there's been a little bit of information overload. For those of you that are interested, it's not possible for all of you to come over and see the demonstration and be able to witness it firsthand, but for those of you that are actually interested in seeing what we're talking about and how we're utilizing electricity to work to fight corrosion, you can walk over here, do a little quick demonstration. You can see some of the examples of how it works, and then if there's more, we can just kind of shuffle them through. So I'll leave it to those of you that are interested on over, and if you're not, we'll just wait for lunch.
I think we had the lunch ready tonight. Yeah, so let's go ahead and start. Some of you will join Mr. Nelson to see what the demonstration is, and we can start the lunch now too. Enjoy your lunch.
Gracias.